Write a C++ program to perform the matrix addition, multiplication, and transpose operations. In this program, we are using the concept of pointers to pointer to represent a two-dimensional matrix or an array. First, we are writing a function which is named as read to accept one matrix value. The read method takes three parameters. First, m is the number of rows, n is the number of columns, and third parameter is a character array to represent the matrix name. The return data type of the read method is a pointer to pointer that represent the matrix or a two-dimensional array. In order to create the memory for two-dimensional array or pointer to pointer, first we need to create the memory location for the number of rows. So there are m number of rows, so that is why we have written int double star equals new int star of m. So it will create m number of row heads. Now by using a for loop, we iterate the number of rows starting from 0 to m minus 1. Now in each row heads, we need to create n number of columns. So before we are accepting the values into the matrix A, for each row heads, we need to create n number of columns. So we write A of I, where here A of I represent the row heads. So each row heads should be capable of storing n number of columns. So A of I equals new int of n. Here m represent the number of rows and n represent the number of columns. By using another for loop, we iterate the index variable j for the columns from 0 to n minus 1. And we accept the value of each element by using a cin statement in A of ij. After the iteration of both the for loops, outside the for loop, we return the matrix A, which is a two-dimensional array or a matrix. Next, we are writing a method which is named as display, which is used to display the element of matrix. It takes two parameters. First one is a pointer to pointer that is used to represent the matrix to be displayed. The next two parameter is m and n. M is the number of rows, n is number of columns. And fourth parameter is the name of the matrix, which is a character array. First, we display the name of the matrix. Then by using two for loop, we iterate all the elements present in the matrix A. The outer for loop with the index variable I is used to iterate the row numbers starting from 0 to m minus 1. And the inner for loop with the index variable j is used to iterate all the columns starting from the index 0 to n minus 1. By using cout statement, we display all the elements cout aij. After displaying all the elements of one particular row, in order to go to the next row, we write cout/n. So the matrix will get displayed row by row. The next method we are writing is a deallocate method, which is used to deallocate the memory allocated for double pointer, pointer to pointer. It takes two parameters. First one is a double pointer whose memory need to be deallocated, and second one m, which indicates the number of row heads present in the double pointer. While we are deallocating the memory for a double pointer, first we need to deallocate all the memory which is allocated for the number of columns present in each row heads. So for that we are writing a for loop which iterates from 0 to m-1 for each row heads, and we write delete a of I. So it will delete all the columns of a of 0, a of 1, a of 2 till a of m-1. After deleting that, we are deleting the entire row heads by using delete a. So first for loop is used to delete all the columns present in each row heads. So a of I. Next, after that, we are deleting the entire row heads of the double pointer by using delete matrix A. Next method is add. Its return data type is integer double pointer, which is used to return a matrix after the addition. The first parameter is a double pointer A, which is used to represent the first matrix, and the next is double pointer B, which is used to represent the second matrix that need to be added, and M and N is the order of the matrix, order of both the matrix A and B. Before we are going to perform the addition operations, we are creating a double pointer variable which is used to store the result. First, we created the number of row heads by using int star m, new int star m. M represents the number of rows to be created. In each of the rows, we have to create the number of columns. So we are writing C of I equal to new int of n. N number of columns are required. By using the for loop, we are iterating each element of the matrix A and B, and that will be added and stored into the matrix C. So we write C of ij equals A of ij plus B of ij. From each corresponding positions from the matrix A and matrix B, the element will be taken and that will be added and stored in the matrix C. After the iteration of both the for loops, outside the loop, we return the matrix C, which is the addition of both the matrix A and B. Next, we are writing a multiply method, which is used to multiply two matrices. The return data type of the multiply method is a double pointer that is used to represent the multiplication of both the matrix A and B. The first parameter represents the first matrix, second parameter B represents the second matrix. Here we are passing the order of the first matrix M1 and N1, which is the row number and column number of the first matrix. And the next last parameter N2 is the column number of the second matrix B. Here we are not passing the parameter M2 because M2 and N1 needs to be same while we are multiplying the matrix A and B. The number of columns of the first matrix A should be same as the number of rows of the second matrix B, which is M2. Now the order of the resultant matrix after the multiplications of matrix A and B will be M1 by N2. So first we are creating the row heads depending upon the size of M1, and we are creating the column heads depending on the size of N2. So each C of I equals new int of N2 because we require N2 number of columns in each of the rows of the resultant matrix C. Now in order to multiply, we are writing the logic wherein which each rows of the first matrix will be taken and it will get multiplied by the corresponding elements of the columns and it will get added. So we are writing, first we are initializing the C of ij as 0 before we are performing the multiplication operation. The element has been multiplied by using C of ij plus equals A of ik into B of kj. The logic for performing the multiplication of each row get multiplied with each columns of the second matrix and successively the elements will get added. After the performance of all the matrix elements multiplications of A and B, the result will get stored into the matrix C and that will be returned. Next method is named as transpose, which is used to transpose the matrix. The return data type is a double pointer which is used to return the transpose of the matrix A. It takes the parameter first A represent the matrix and M and N is the order of the matrix A. Now while we perform the transpose, the resultant matrix, the row and column number will be the reverse of the original matrix A. So the number of row heads need to be created for B will be the number of columns of the matrix A. So we are creating the row heads for the matrix B depending on the value of N. And in each row heads, we need to create the number of columns and the number of columns required for the matrix B will be the value of M. So we are writing B of I equals new int of M. So first we create n number of row heads and in each row heads we are creating m number of columns that is used to store the transpose of the original matrix A. So in order to exchange the elements depending on the row and column values, we are writing the logic as B of ij equals A of ji. After the iteration of both the for loops, outside the for loop, we return the new matrix which is named as B. As a resultant, that will be the transpose of the matrix A. In the main method, we are using a do-while loop for repeating the operations of matrix addition, multiplication, and transpose operation. We have declared a variable which is named as ch, which is initialized as 0. After that, inside a do while loop, first we are displaying the menu options for performing various matrix operations. We are displaying like 1 for matrix addition operation, 2 for matrix multiplication, and 3 for matrix transpose operation. By using cout object, we display all the possible matrix operations: addition, multiplication, transpose. The value of the choice will be accepted in the variable ch. Now, depending on the value of ch, we need to perform different matrix operations. Before that, we are declaring some variables which is required for this particular program. M1 and N1 used to represent the order of one matrix, M2 and N2 for the order of second matrix. We declare three double pointer variable X, Y, and Z. In the switch case block, first we are writing the code for the case 1. So case 1 is for matrix addition operation. So in order to perform the matrix addition operations, first we accept the order of the first matrix, which is M1 and N1, by using cin M1 and cin N1. So M1 and N1 represent the order of the first matrix. After accepting the order of the first matrix M1 and N1, we are reading the matrix element by using read method. It totally takes three parameters. First two are the order of the matrix M1, N1, and the last parameter is the name of the matrix, which is named as matrix X. Similarly, we are reading the second matrix by using read method. The order of the second matrix is also same, M1, N1, and the name of the matrix is Y. Both the matrix can be added by calling the add method. It takes totally 4 parameters. X and Y are first and second matrix that need to be added. M1 and N1 is the order of the matrix X and Y. The resultant addition matrix will get stored into the variable Z. The element of each matrix can be displayed by calling the display method. It totally takes 4 parameters. The first one is the matrix that need to be displayed. The next two parameters M1 and N1 represent the order of the matrix X, and the last parameter indicates the name of the matrix that need to be displayed. So by calling the display method 3 times, we display the element of the matrix X, Y, and Z. So all the three matrices here, the order is same, which is M1, N1. Once the result has been displayed, we can deallocate the memory which is allocated for each of the matrix X, Y, and Z by calling the deallocate method. It takes 2 parameters. First one is the matrix name, and the next parameter is the row number of the matrix. The row number of all the matrix X, Y, and Z is M1. Now we have to write the logic for the case 2, which is matrix multiplication operation. For matrix multiplication operation, first we need to take the order of the first matrix. So the order of the first matrix is read from the user and stored into the variable m1 n1 by using cin statement. Cin m1 n1. And the elements of the first matrix can be read by using read method that takes three parameters: the order of the first matrix m1 n1 and the name of the matrix, which is matrix X. And the resultant matrix after reading will get stored into the variable double pointer variable X. Similarly, we accept the second matrix. First, we accept the order of the first second matrix as m2 n2, and we read the element of the second matrix by calling read method and store the return value into the matrix variable y. The order of the second matrix is m2 n2 and the name of the second matrix is matrix y. Now we can perform the matrix multiplication operations only if the column value of the first matrix is same as the row value of the second matrix. That means we need to check the value of n1 and m2 both are same. If n1 and m2 both are same, we can perform the matrix multiplication operation by calling multiply method. It totally takes 5 parameters. The first two are the matrix that need to be multiplied. So we pass the parameter x and y. The next two parameter is order of the first matrix, which is m1 n1, and the last parameter is the column number of the second matrix, which is n2. After performing the multiplication operation, the resultant multiplied matrix will get stored into the variable z. So all the matrix x, y, and z can be displayed by calling display method. First, we are displaying the matrix x with the order m1 n1. Next, we are displaying the matrix y with the order m2 n2. And the last, we are displaying the matrix z with the order of m1 n2. After performing the matrix multiplication and displaying the result of all the three matrices x, y, and z, we need to deallocate the memory which is allocated for all these three matrices x, y, and z by calling the deallocate method. Deallocate method takes two parameters. First one, the matrix that need to be deallocated, and the second is the number of rows present in the matrix. So first x comma m1, next y comma m2, and z comma m1. Now in the else part, if the number of columns of the first matrix n1 is not equal to the number of rows of the second matrix, which is m2, we display the message that the matrix multiplication is not possible. and we need to deallocate the memory which is allocated for both the matrix X and Y by calling deallocate method. So deallocate X comma M1 and deallocate Y comma M2. Now in the next case 3, we need to perform the matrix transpose operation. So in order to perform the matrix transpose operation, first we need to accept the order of the matrix. The order of the matrix is accepted in the variable M1 N1. The matrix is read by using read method with parameters. The first two are the order of the matrix M1 N1 and the third parameter which is the name of the matrix which is named as matrix X. Matrix element will be read and it's stored into the double pointer variable X. Now the transpose of X can be found by calling the method transpose. So we have written Y equals transpose of the first matrix name which is X and next two are the order of the matrix X which is M1 and 1. Now both the matrix X and Y can be displayed by calling display method. First display X M1 N1 and the name of the matrix is X. Next we are calling display method for displaying the transpose of X which is Y, wherein which the number of rows of Y will be N1 and the number of columns of Y will be M1. Now while we are displaying the transpose of the matrix X, Y, the number of rows of Y will be N1 and number of columns of Y is M1. The memory allocated for both the matrix X and Y can be deallocated by calling deallocate method. First, we are deallocating the memory allocated for the variable X, matrix X. The next parameter is M1, that is the number of rows of X. In the second, while we are deallocating Y, the number of rows of Y is N1. Case 4 is to exit the program, so we display the message to stop the execution of the program. If user enter any other case value like other than 1, 2, 3 or 4, we display the message in the default that user entered an invalid choice, because we have possible choice for 1 for matrix addition, 2 for multiplication and 3 for transpose and 4 to stop the execution of the program. In the while, we need to write the condition. So as long as the value of ch is not equal to 4, we have to repeat the do while loop. So when the value of ch becomes 4, it will stop the do while loop. So system function, we have to include hash include std_lib.h. Here we have not written deallocate. The word is missing. So after index I, we have not closed the bracket. Execute and see the program output. This program can be used to perform the matrix addition, multiplication, and transpose. Thank you for watching this tutorial.